Hello, everybody. There's a lot of familiar names there, so that's great. You'll know then that you'll need to jump onto that website, joinpd.com, and hook up with that class code. And if you're new, welcome. This is year 8. We're partway through algebra, and we use a interactive program called Pear Deck. And so to be able to interact with the questions when I ask them, you'll need to go to this website, joinpd.com, type in that code, and then you'll be able to answer questions as they come up on the screen and interact with the group. I'll just wait another minute. Actually, I might start because I've got a little bit of a refresher from last week, and that'll give those who are turning up a little bit late the chance to come and log in and not miss anything from this week. So with the code for today is fragrant quizzes underwhelm acidic quizzes. Let's say that 5 times fast. Okay, so let's just do the housekeeping stuff while people are turning up. So welcome again, year 8. Last week we started algebra, and today is the middle of 3 sessions that we're doing on algebra. The normal housekeeping that we cover is, we can't cover everything that you would normally do in school in just this 1 hour a week, although I try really hard to make sure I've repeated the real key points and concepts. That's the essential takeaways from the chapter, I suppose. Because we have to follow some sort of order, we do follow the Mathspace curriculum. If you want to log in to be able to access the questions that I show during the session, that's entirely doable. You just need to ask your teacher and they can get access to Mathspace. All of the recording of today and the slides that I use will be available at that website. So mathspace.co/au/academy. And that way you'll be able to watch it again, pause it, do the questions, go at a different pace, and do some of the other, maybe because, you know, I'll give you options as we go through today, and you might want to go back through the slides and do the other questions that you didn't choose to do today. Just a little bit about Zoom that we're all using. I know we've got a lot of repeat people here, but there was a couple of new names, so just make sure you've found the chat. And that you found the QA. So if you've got a question specifically of myself or Miss G or Miss J, Renelle, who's around, put it in the QA section, and then we can answer that, or we can make time at the end to go through any clarifying questions. So a bit about us. We've still got a few people coming, so we'll just keep going with our normal housekeeping stuff. So as I say every week, we'd give you a little bit more info about us, just because I figured if we were in a classroom all together, you'd be bored to death about all the stories I tell about my animals. But that's the theme of the week this week, is animals. So I've got a lot, actually. I have 2 dogs, 2 cats, 2 sheep you can see in the photo there. That's Douglas and Stanley. I've got 10 ducks and 40 chickens. Well, actually, my partner has 40 chickens. And Michelle, what about you?
Yeah, so we're definitely a pet family. We have, but not quite as many animals as Miss G, but we have Chloe. She's a elderly Chihuahua, and you can see in that picture there, that's her pose about 95% of the day. If she's not doing that, she's getting herself a snack. And then we have 2 cats, Edison and Arwen. Edison was actually a gift to me from one of my students, so it's really a great connection to have him from when I was teaching in the classroom. And then we have Arwen, of course, who is a rescue from an animal shelter, and so she has the typical grateful temperament of being a rescue animal. So yeah, we are definitely loving our fur babies here in AU.
Yes, so I mean, I have a lot because I live on a little mini hobby farm, I suppose, but just as a way of getting to know a bit more about each of you, and to generate some interaction so you get used to the Pear Deck if it's your first time, So this is just our introduction to the interactive. So on your screen now, if you've joined the Pear Deck, you'll have a little kitten icon. And I just want you to drag that into the graph that we'll create now. Do you have animals at your place? So whether you have none, 1 or 2, 3 or 4, or more than 4, fish count, that's fine, why not? And yeah, so just drag it in there. It's just a way to make sure that everyone's in the Pear Deck that we need to have. So Miss J, if you could paste the details again in the chat. I see that we've only got about 13 logged in, but about 20 people in the room. So just to make sure everyone, yeah, so if you just got one, then just put it in the 1 or 2 section. If you had one, sorry to hear that that's a past tense. So depends on how much they're in your heart. If you feel like they're still there, then you can keep them there. That's fine. Yeah, so it's joinpd.com. So I'm just going to put up the answers. Oh, a few more people have come in. That's great. So here's our cats flying around on the screen. So see if you can line up your cats so that we create a bit of a chart. So move them a bit over if they're on top of someone else's cat there. Just move it in. Yeah, there's a lot of people. Yeah, great. That's fantastic. Just move them in, move them in. And I'm going to lock that responses. So get it in the right place. I'm going to lock it in 3, 2, 1. Brilliant. There we go. Okay. So, well, isn't that interesting? Not many people have animals at their place. I was actually expecting a bit more than that. So just might be a matter of the location, I suppose, about where all the students in the okay, that's our interaction. Kind of works. You'll have something to do or write or contribute to. Okay, so where are we? Last week we started algebra. We talked about like terms and how to add and subtract and multiply and divide. And this week we're on to part 2. I've changed it a little bit. We were supposed to do expanding and factorising, but because factorising is quite a tricky bit, I'm going to do that next week. Focus this week just on the expanding, and at the end we'll just do a little bit of substitution. So I really want to make sure that we get these key concepts under our belt. So a lot of algebra, here's the truth, right? I could make up a question and say, here, this is where you'll use it. But really, you'll get to that part of your life and you probably won't use algebra that way. But the thing about algebra is that it's a way of thinking that's really important in mathematics. So it's a way that gets us to think about things in terms of being abstract, or being able to replace something with something else, being able to generalize, form patterns. And we do use it a lot when we get to, later maths, but, this type of algebra, adding and subtracting like terms, it's really just a skill. It's like, for example, when you're learning to do some sort of sporting activity, maybe you play softball or baseball or something, there are some specific skills you need to know how to do, and you'll just practice them. Not because that's exactly how you'll do it when you go and play the game, but because those skills are important to have under your belt. And algebra is a lot like that. There are some real specific skills that are important to us. So I don't want to, fluff it up and make it sound like it's, you're going to use it next week, or you're going to use it when you go shopping. You probably won't, but it's still really important. So that's why I want to go slow and make sure that you have these skills. So I always mention this: if you want real specific teaching videos on each of the items in the chapter, you can go to YouTube and watch the teacher of the year, Eddie Wu, do his stuff in his classroom. So that's there if you want to do some stuff in more depth. So I've got another interactive. It's a revision on something that we did last week, talking about like terms. So you've got 5 dots on your screen. I want you to drag them to anything that you see on the screen that is a like term with the term. So just drag those icons in where you see things that are like terms. That's a good revision about where we're at from last week. So remember, a like term has to have exactly the same combination and presentation. So I can see on my screen lots of dots flying around. We're doing very well. Doing super well, in fact. So I'll just point out I'll point out one now that's not a like term. So 765a squared b. Oh, thank you, Fergus. Yeah, I've got this very windy day here, and a little bit. So 765a squared b is not a like term. And the reason for that is it's got the squared in there. So for example, a squared b is actually oops, I pressed the button again, is AAB. So it's not the same as AB. So that one is out. So people still moving their dots around. I'm going to rule out another one as we're going. For exactly the same reason, B squared A here is not a like term because it's BVA. B times B would be B squared. So that's not a like term either. So I can still see some dots flying around on the screen. There's one more I can see there that's not a like term. Oh, actually there's two more. So here we have ABC. That is not a like term because this is A times B times C. It's got three things in there. It's different to the term AB, which is A times B. So they're different because this has got a whole other multiple in it. So if you had A, B, C, you can move that dot off there because that one is not a like term. There's one more that isn't, and this is a tricky one. This does trick some people up. So I'm just going to tick a few. A, B, correct, because this is just a -1 out the front. And like terms have the same combination of letters, so that does, and it's just got a value out the front of -1. This part here of the expression, that is a term, and so that is okay. That is AB. So if you've got on the first part of that, well done. Minus BA is a like term. It doesn't matter the order of the letters as long as it's got the same combination of letters. So this and this, they're exactly the same, these two, just written in a different order. So that is a like term. 4AB is a like term. That's absolutely fine. It's just got a different value out the front. And so too this one. That's exactly the same like term, AB, just a different value out the front. So that means we've got one left over here that is not a like term, because over here we have 2A plus 2B. They are two separate terms. This is very different to the term AB on its own. So that is not a like term. We can't just combine them together written as AB when they're adding, because this is A times B, which is a multiplication, which is very different to addition. So that's where we're at. So well done, everybody. Okay. Close that. Oops, got to get rid of all of those drawings. There we go. Okay, so from last week, I left you with a little bit of homework. It was just lines in our puzzle using some kind of algebra. Now, there'll be lots of different answers for this. I'm just going to show you mine. And it was just because it was an exercise in being able to simplify, because here I had one chicken plus 1, 2, 3, 4, 5, 6 eggs, as you can see from here, 1, 2, 3, 4, 5, 6. And so I could simplify that expression to C plus 6E. So it doesn't matter exactly what letters you used. And like I mentioned last week, if you interpret that as just one egg basket, then that's fine. You'd have different expressions. But the key thing is being able to replace objects in a story with a letter to be able to do some maths with it. And that's kind of the key part of algebra. Okay. So on to this week. So we're doing expanding. It's called the distributive law. Now's a good time for me to show you the book because we're doing 404. So this is the Mathspace textbook. Now, you don't have to use the Mathspace textbook. In fact, I don't know how many of you do, but what matters though is that this is Year 8 content all around Australia, and you'll have a Year 8 textbook probably in your hand, and they'll have a chapter on algebra. And so the section that we're doing today is called the distributive law. Your book might call it expanding expressions or expansion. So anything like that will be the right place in your book. So this is our book. Our book has a lesson page. It's all digital, not a printed copy. So here's the lesson, and I'm going to go through a bit about these rectangles and things coming up. And then we've got some practice questions. Some of them have a video that you can watch to hear how a teacher would solve the problem. And then there's a big pile of questions. So I'm going to do some of these as examples today. And then depending on how you go, we'll come back and do some of the harder ones as well. So we're looking at whatever book you've got. It'll be in the algebra chapter, a section on expanding, distributive law, expansion, something like that. So the way that I like to start talking about expansions is to go back to something more simple, and we call this the empty rectangle. It's a rectangle that we then just mark up however we like. So it always starts off empty, if you like. And we go back to where we started in primary school, looking at the area of a rectangle, and remember that the area of a rectangle is the length multiplied by the width. We're going to use that to help us understand how we multiply algebraic terms. So let's just go over this area. So the area of this rectangle would be length times width, which is 8 times 5, or 5 times 8, which would be 40. Okay, so you just multiply one side by the other. And we can do that even if there's a letter there rather than a number. So in this case, the width is A, but that doesn't matter. We can still find a representation for the area. So in this case, the area would be 7 times A. We write that as 7A. And then if later on down the track, someone said, oh, I know the width now, the width is 2, you'd be able to work out what the area is because you could substitute it in. You could evaluate it or work it out. We can do that even if both of the sides are just written as letters. Maybe we don't know what either of them are. They're sort of just a representation of a rectangle. So in this case, we would just have the area is m times n. And so that would just be written as mn. Now remember, we're going to use all of the skills that we developed last week. Adding and subtracting, you need to know like terms. Multiplying and dividing, we talked about how we write those letters together. So when we multiply m times n, we write it as mn. You don't need to write the times sign in the middle. So if you have a bit of trouble with that still, it would be really worthwhile to go back and do some more practice in that area before you get too far on, because you don't want those small skills holding you up on some of these more tricky ones. Okay. So, and we can even do this area idea if one whole side length, like this length down here, is an actual expression rather than just a letter. So let's see what that would look like. Then in this case, the area would be length, which is A plus B, all multiplied by D. So when we use these sort of grouping of terms, we put these brackets on it because we want to multiply that whole thing by D. And you know that we can multiply things in any order. So just like how in whole numbers, 2 times 3 can be the same as 3 times 2. In this case, we call that commutative. So multiplication is commutative. It doesn't matter the order. It just matters that we're multiplying both of them. And that doesn't matter if the A plus B comes first, and then we multiply it by D, or we have the D first, and then we multiply it by the A plus B. They're exactly the same. We get to what we call mathematical conventions, and I talked a little bit about that last week. It's kind of like the grammar of the mathematics, if you like, you know, where we have capital letters and full stops. So in the mathematics world, we have some conventions, and in this case, one of the conventions is we would put the little single term out the front of the brackets, and we would not write the multiplication sign. So that's some of the conventions. It's kind of like shorthand. It takes away some of the all the extra stuff that we don't need to write down. So let's look at another way now to write that same area. So what if we wanted to write this a different way? So let's look at the length A plus B as being made up of two parts. You can see here that we've got two parts. One is of the length A, and that's this piece here. And here is the length B. So altogether, the length is A plus B. I'm just going to split that up into two smaller rectangles. Well, we would know that, or we could find, for example, the area of each of the smaller rectangles. So the area of this particular one here would be length A times width D. That's the area of that smaller part. The area of this one over here would be length B times width D. So what we had before was this representation, the whole length times the width. But now we've found another way of writing it. And so we can actually say that in this case, the area is also equal to AD plus BD, because the area of the big rectangle will be the same as the area of the two smaller ones added together. And this is in fact demonstrating exactly what we're about to do, which is expanding the brackets. These two are the same, they're just different representations. One is using the brackets and one has no brackets. So let's see what that does. Next slide. That's just what I showed you before. So they are the same representation, the same value. Okay, so now we're going to expand. We're going to use this rectangle to do some expansions now, a bit like a bit of a prop. So I'm going to show you first, and you can see I've got my turn up the top there, how to expand the expression 2 bracket x plus 3 using this rectangle method. So the first thing is to put some of these numbers on their rectangle. I'm going to use this x plus 3 piece as the length, because I'm going to split that up into two parts, one part x and one part 3. So there we go, that's putting on the diagram. So you can see here we've got the width here is 2. We've got the length as an x plus 3. So the full length is x plus 3. But I'm just going to look at it as being one part length x and one part length 3. So then we can find the area of each of those smaller rectangles. So 2x here would be just 2x, length times width. And over here I've got, well, a rectangle with a side length of 2 and a side length of 3 would have an area of 6. So altogether, we can see that the area is 2x plus 6, and there is our expansion. So we can expand 2 bracket x plus 3 to be 2x plus 6. Okay, now there's a your turn slide coming up. You can pick one of these 3. This will give me an indication too about how comfortable you are with them. If people are choosing the easier one, like what I've just done, I'll know to do a few more. If people are choosing the more hard one, then I'll know I could move a bit quicker. So you've got 3 here to choose from. I want you to put the diagrams on the rectangle, show me the area of each individual piece, and then find the expansion. Okay, I'll just watch your responses on the dashboard. Excuse me, just find my water. So when you logged into PEDEC, you'll have been given an animal name. So that's the name that I'll reference, of course. So, so what have we got here? Yep, squirrels on the right track, fantastic. Pterodactyls on the right track, well done. Wolf, yep, on the right track, fantastic. Starfish is doing well. Yep, well done, seahorse. Good work. can see you're a bit stuck, course, so I'm going to start you off on one if you like. So I'm going to annotate on this screen. So keep going doing the one you're doing. Oh, you can't see which animal you are. I'll have to Google how you guys can do that. Okay, so if you're a bit stuck, I'm going to start with the easy one first. The first one, which is very much like the one that I started with. So I've got 3 lots of x plus 5. So I'm going to put the x plus 5, I'm going to split that up along this length here where I've got 2 pieces. So I've got x and 5. So altogether that length is x plus 5. That leaves the width as 3. So it goes up here. And then the area of each rectangle is going to be length times width. So in this first case, it's going to be x times 3, which we would write as 3x. In the second one, it would be 3 times 5, which I would write as 15. So the answer to this first one would be 3x plus 15. So there are a few people that are a bit stuck. If after watching that one, you want to have a go, I'm going to clear this out now. I'll set up the second one for you and you can try and complete that one. So here we have 2x plus 7. That's going to be my full length, 2x plus 7. I'm going to split that into 2. The 2 parts here are 2x and the other part is 7. And then the number at the front is 7. So there is the setup for the rectangle. So if you haven't yet had a go, there are a couple of people who are a bit stuck. Have a go now. I've set that up for you. What you need to do is find the area of each of these smaller rectangles. And we find the area by multiplying the length times the width. Yep, Puffin's got it. Oh, you don't know if you're a puffin. I love puffins. I used to think penguins were pretty cute, and then I started seeing some puffins. I'm like, I think they're better.
I was at a zoo one time, and they were describing the puffins as flying potatoes. So now anytime I see one fly, that's all I can think.
Okay, so we'll wrap this one up. So the answer to this one would be 2x times 7. Now, remember when we did multiplying terms, Miss G's tips were numbers first. So 7 times 2 is 14, and then write down all the letters that you have. So that first one is 14x. In this last one, we have 7 times 7, and that's just numbers. So 7 sevens are 49. So the answer to that one would be 14x plus 49. So quite a few people got that right. Well done, everyone. And I might as well just do the last one because that'll clear it up. It'll be on the recording then for anyone who wants to see it. So the last one is 5 plus 3b is the long length that I can split into 2. I'll split that into a 5 and a 3b. The first term is 2a. So it's 2a times 5 plus 3b. Okay, so when I multiply these together, it's length times width, so 5 times 2a. So Miss G's tips were numbers first, 2 5s are 10, and then write the letters that you have. So we have an A there. In the next box, we have 2a times 3b. So numbers first, 2 times 3 is 6, and then we write down all the letters that we have because we're multiplying them together. So this whole box would be 10a plus 6ab. So lots of letters in that one. And some people did that very well. So well done if you chose that one and you got that right. Okay, good job, everybody. Okay, so again, a reminder, we call this the distributive law, okay? And then now the process works. We don't always need the rectangle, but if you get stuck, you can always draw one in your book, okay? So I'm going to show you now how we can do this without the rectangle. And you may already have seen this. It's kind of a bit of a shortcut. And sometimes books just teach this straight up without using the rectangle, but I think the rectangle helps get a real picture for it. So here is a way to do this question without drawing the rectangle. What we did is actually, I'm going to draw a rectangle so I can show you the connection. So here we have the rectangle of 5x plus 6. There's our little dotted line, and we're multiplying it by 4. So if we were doing the rectangle method, we would do 5x times 4, just like I did on the previous screen. Numbers first, 4 5s are 20, write the letters, so we get 20x there. And this last one would be 4 times 6 is 24. Now what you see that we did here is we multiplied the 4 by each of the terms. We multiplied the 4 by 5x, and then we multiplied the 4 by 6. So we'll do the same over here. Multiply the 4 by 5x, multiply the 4 by 6. So it's important that when you've got the brackets, that everything inside the brackets is multiplied by the term outside the brackets. Okay, so to do this without drawing the rectangle, you would just go 4 times 5x, and you could write it out in full if you like while you're learning, plus this next term of 4 times 6. And we would get then numbers first, 4 5s are 20, and 4 6s are 24. So you see we get exactly the same numbers, but we don't need to draw the rectangle. But the process is exactly the same. And the way it works is because we were multiplying the 4 by every one of the terms that were in our rectangle. So I'll clear that out. We'll do another one. I've got that written on the slides in case people come back to it. Okay, here we have 2 groups of 3 plus 2x. So without the rectangle this time, let's just look at what this means. It means we're going to take the 2 and multiply it by everything inside the brackets. So the first one is 2 times 3. That's just 6. The second term is 2 times 2x, which is numbers first is 4 and then an x afterwards. So we have 6 plus 4x. Yeah, well done. There's some people there throwing some answers in the chat. That's great. So clear that out. That was my turn. Now it's your turn. So on the next slide, you're going to have one of these two to do in terms of the expansion. You want to expand one of these, don't mind which one. Try and do it this time without the rectangle. So just choose one, or you could split your box and do both of them on the screen if you like. That would be fine too. There's probably plenty of room. So I'm just going to turn to the side so I can see your responses. Yep, Clownfish has done it. Well done. Yep, Pterodactyl's got it. Geez, I wish you knew what animals you were. Yep, Puffin's got it. So the answer to the first one, most people have jumped to that one. Here we go. So I'm going to do the first one over here. We've got 8, 4x plus 2. So again, the 8 needs to multiply everything inside the bracket. So it needs to multiply this term, and then it also needs to multiply this term. So I'm going to have 4 8s are 32. Well done. Oh, so you can work out what animals you are. Hey, Tanvir knows that they're Puffin. Tanvir, can you please put in the message to Miss J how you know that so we can tell everyone else? And then 8 times 2 is 16. So the first one is 32x plus 16. So people are still working. I'm just going to throw out the second one. So we've got everything outside the brackets multiplied by everything inside. So 2b times x plus 2b times 3. So that's the term, the first one, and the second one. Okay, so 2bx just becomes 2bx. We multiply, we just write all the terms side by side. Over here we have numbers first, so 3 times 2 is 6, so we'll end up with 6b. Now remember, they are different terms. They are not like terms because this has an extra x in it. So that is as simplified as we can get. We can't add those two together because they're different terms. Okay. Okay, now, what about other things like negatives? Negatives are the thing, we sort of do everything. You'll see all the questions I've given you so far have all been positive numbers. As soon as we throw in some negatives, errors creep in, and that's just because we probably move a bit too fast, and we have to remember our rules about multiplying when it comes to negative numbers. So right back last week when we talked about this, same signs positive, different signs negative. Okay, the process is still the same. It's we multiply the number out the front by everything inside the brackets, but you've just got to watch your sign. Okay, and Miss G's tips for that: one step at a time, take it slowly. Okay, so here's an example. This is my term. We've got 4 multiplied by 2x minus 5. So when we do that, each term, the 4 times 2x becomes 8x, and 4 times negative 5 is negative 20. Okay, here's a second example that uses negatives. I'll expand this one out for you to see a bit clearer. The first term is minus 3 times 2. So it's everything outside, which is the whole minus 3, times each of the terms inside. So the first one is times 2, and then we add to that the second term, which is minus 3 times minus 4x. Okay. Now we multiply together. 2 times negative 3, negative 6, because they're different signs. Different signs means negative. Over here, I've got negative 3 times negative 4. So numbers first is minus 3 times minus 4 is 12. It's a positive 12 because they're both the same sign, and I still have the x. So this one would be minus 6 plus 12x. Okay. So it can get pretty, there can be lots of letters, and we still just have to remember all our rules for additions and subtractions and multiplications and divisions. So in this particular case, let's do this one. This is my turn. Your turn's coming up. This is the whole term, this is a whole term, and this is a whole term. Okay. It's each term outside multiplied by each of the terms inside. So we've got minus 3b times negative 2a. The second one is, that's this first one. The second one is minus 3b times 4g. Okay, so you're just going to do them piece at a time. Write it out if you have to. Don't do too much in your head. That's where most of the errors around forgetting negatives creep in. Minus 3 times minus 2. They're both the same sign, so it will be a positive answer of 6. And we've got a B and an A. Remember, the convention is usually alphabetical order. Plus, the second term is minus 3 times 4 is negative 12. And the letters we have are B, G. So now what do we have? This is a common mistake where students would leave it here. We have one more step to fully simplify. So to fully simplify this one, we have the 6AB. We generally, this is a convention, I remember, that we don't have the side-by-side signs. If we're adding a negative, we just write the subtraction, minus 12BG. So that's one of our conventions from adding and subtracting. Okay, so we've got a your turn coming up now. That was a pretty tricky one. We had multiple letters, we had negative signs, and then we had the adjoining plus minus here to simplify. So it was a pretty tricky one. We'll see how we go on the your turn slide coming up. Okay, here's your turn. Just the one question this time. Want everyone to give it a go. So when you go in, just remember to take your time, watch your negatives and your letters. Hey, Goose, just watch your negative signs there. Get well done, Rabbit. Pterodactyl, well done. Have a go, Ladybug. If you're a bit stuck, I can start you off. Let's turn on the pen. Okay, so minus 5m multiplied by 3r minus 2t. So the first part will be minus 5m times 3r. That's multiply the first term. Then we're going to add to that the second rectangle, if you like, remember? So it was minus 5m times minus 2t. Okay, so numbers first, 3 times 5 is 15. M, R are the letters I have. In this next case, numbers first, 5 times 2 is 10. M, T are the letters I have there. So that's what we want to get to, minus 15 MR plus 10 MT. Yeah, that's fine. It is hard to write sometimes on the digital devices. It's certainly hard to write right on the screen if you're using a mouse. And yeah, it doesn't matter how messy it is. I'm able to see, I'm able to interpret student writing. I've been doing that for a long time. A bit like being able to read doctor's writing, I think. Okay, well done, everybody. That was good. There was just a couple of people who had the sign wrong for the second term, so you just need to be careful of that. The negative times the negative was a positive. Well done. Okay, now I'll just check the time. You're doing well. Okay, this slide, it's not for us to do now. I'll put it up again at the end. It's a challenge for next week. We're going to use the same process, but now some of these have 3 terms, and that second one has 2 lots of 2 terms. So think about how you could draw a rectangle that would represent those. So again, that's not for now, just something to think about, and it's a bit of a challenge for next week. So just while we're finishing off this week, I want to talk about substitution. So if you substitute something, that's like just to replace or swap one thing out for another. So if you're cooking and you are plain flour, you could use, in most cases, self-raising flour, you substitute. If you are vegan and you don't want to use butter in your recipe, you could substitute it for applesauce, something like that. So it's just when you swap one thing out for another. And in mathematics, we normally mean substitution to mean, let's swap out a letter for an actual value that we now know. And so that means substitute. We put the number in, and then in most cases, it means you can evaluate it, work it out, or simplify it a bit further. So my tips are, do one step at a time. I always say that. That should just be number 1, Miss G's tips. One step at a time. Slow it down. Do one step at a time. Make sure to uphold the same value, so don't sort of replace it with another thing, but also don't forget powers. You know, if you've got powers, it's one thing times another, then that means it's going to be that value times another. So evaluate them for what they are. So here is some examples. So if we're going to evaluate this expression, m plus 3p minus 7. So let's go back. Yeah, let's just do it here. Should have left it blank for you so I could show you. So here we have an expression, m plus 3p minus 7. And we're going to evaluate that for when m equals 12 and p equals -2. That just means substitute in the value of 12 every time you see it, the letter m, and substitute in the value of -2, wherever a p is. So you'll see over here what that does is we put the 12 in for the m, we put the -2 in for the p, and now I've got no letters left, so I can evaluate it in full. So what I have here is 12 plus 3 times -2, which is -6, minus 7. And then when I've got 12 minus 6 minus 7, I end up with -1. Okay, so you just need to substitute in one letter, one value for each letter, and in each time it occurs. So let me do an easier one for you that uses the same values. If we just had m plus p, what would that evaluate to? Well, when m is 12 and p is -2, then the answer would be, 10. What about if we did m minus p? Just throw that in the chat if you like. When m is 12 minus -2, so the minus and minus becomes a plus, so 12 plus 2 is 14. Okay, let's have a look now at another simple one. What about 2m? When m is 12, it's just 2 lots of 12, which is 24. Okay, so we could do something more complicated like m squared. Well, we know that to be m times m, and every time there's an m, it's going to be a 12. So that's going to be 12 squared, which is 12 times 12, which is 144. Okay, now we could do even, I'll do one more, m divided by p. What do you get for that one? So you've got m is 12, p is -2. We're dividing and they're different signs, so I know the answer has to be negative, and 12 divided by 2 is 6. Okay, so we've gotten the idea. That's really good. Let's do another one. Okay, oh, there's some more examples. Let's do these ones. So on the next slide, you've got 4 options here. We're going to evaluate them. The values for P and Q are on the next slide. You can do them all. If you're on top of it, you can just do one. I want everyone to at least try one. It's really important that I can see that you can all do some evaluation. So all we're doing is substituting in the values for P and Q that you see there. And just because the font is a bit unclear, this Q is a -2. So be mindful of that up the top here. That's a negative. So don't mind which one you do. You can do them all, like I said, but definitely please try and do at least one. You can see most people starting there in the slides. That's fantastic. So Seahorse, remember we want to substitute in here. So you probably don't have to expand to substitute. I'll start with this one. I mean, you can expand first, that would be fine. But I'm going to do this one, P times Q. So it's P times, so it's 4 times Q minus 4, which is -2 minus 4. That might be one way to start that question. If you're looking for a start on one of the others, here we have PQ, which is 4 times -2 minus P, which is minus 4, plus Q, which is minus 2. If you're looking for a start on this one here, that's P cubed. So that's going to mean P times P times P. Yep, people are working away. That's fantastic. So let's have a look at a start for this one. 3 times 4 squared minus 2 times P plus 6. There's no Q's in that one, just with just the letter P to substitute in. Okay. The next one, I'll start off this one here. That way everyone's got to start. P cubed will be 4 cubed minus P squared, which is 4 squared, minus 6Q, which is 6 times minus 2. Alrighty. So hopefully you're still working away. I'm just going to check your results here. Oh, that's okay, Goose. Don't give up. Just clear it out, delete your response, and try again. We can do it. Pick up one of the ones that I've started and try and continue on from there. All right, next line of working. So I'm going to go to this one first. So equals 4 times minus 2 minus 4 will just be minus 6. So this one would be minus 24 when evaluated. Numbers first, 4 times 6 is 24. Different signs, negative. Okay, let's do this one next. So the next line would be numbers first, 4 times minus 2 is minus 8, minus 4, a plus minus becomes a minus 2. So my line is minus 8, minus 4, minus 2. So that's going to be minus 12, minus 2 more is minus 14, negative 14. Let's jump up here now. So this is going to be 3 times 4 squared. Well, 3 times 4 squared is 16, minus 2 times 4 is 8, plus 6. 3 16ths, that's a stretch. 3 10s are 30, 3 6s are 18, so that's 48, minus 8 plus 6. So 48 minus 8 is 40, plus 6 is 46. One more to go. 4 cubed. So 4 cubed is 64. 4 squared is 16. And then we have 6 times 2 is 12. We've got minus 6 times minus 2. So it's going to be positive 12. Okay. And then that gives us 64 minus 16 plus 12. So that's 64 minus 4, which is 60. So there's some great answers there. I did see just a couple of you get a little bit frustrated, so that's okay. This is a recap, and if you need to, you can go back over and watch the video again. You can go back to your textbook or the Mathspace textbook and do a bit of practice. But where I saw most students getting a bit stuck was not in the actual substitution. It was in the evaluation involving negatives. So make sure that you're okay with that. We operations in chapter 1, and all of your books will have a section on integers or negative numbers. They'll call them something like that. So if you get stuck on those, go back there, because that's really important that we get good at and working with the negatives. Okay, so clear that, close that, moving on. Okay, so we've got a little bit of time for Q&A. Whilst I go and check the Q&A panel, I'm going to leave you this screen. This was your challenge for next week, okay? To pick one of these and try and do 2 things. The first one is, can you draw them using the rectangle method? Like, can you give me a visual representation for what this could look like? Remember that whole sort of length times width idea. One or both, it's up to you. And then once you've done that, do the expansion. So find the areas of all the smaller rectangles and add them together. So that's your challenge for next week. I'm just going to check with Miss J if there's anything unanswered in the Q&A.
Yeah, just one question on one of the very first problems that you did. They were asking about the signs.
Right. Let me see if I can. Is it worth just going over that particular question again then, Miss J? Or should I?
Yeah, I think that you had -5 instead of +/5. So you
Sure.
have, yeah, so talking about whether it's how that sign works there.
I'll just see if I can find the question. And then I'll do it again. We've got a bit of time. Oops. See if we can find the question. We got to negatives, we'll be a bit on from there. Maybe this one?
Yes.
Yeah, okay. So I'll just do this one again. We've got a little bit of time. Again, whilst I'm going over this, if you have an outstanding question, please put it in the Q&A and I can answer it before you go. This particular question was, I'll just write it up here so I've got a little bit more room on my tablet to write, 2x minus 5. Okay, so here we have 4 times 2x and 4 times -5. So the negative sort of belongs to the 5. That's the whole term, is -5. In mathematics, we assume everything to be addition or multiplication. So this is really 2x plus that value of -5. We just use this shorthand whenever we see these adjacent signs to write it as a negative. But one of the decoding things you have to do when you're working with these things in maths is understand that the negative belongs with the 5. So now when I do the multiplication of the outside times the inside, so the first one is fine. We get 4 times 2 is 8x. Using our rectangle method, it was, that's the area of one of the smaller rectangles, and I need to add together the area of the other rectangle. And the area of the other rectangle is 4 times -5. So numbers first, 4 5s are 20. One of them is a negative, so that will be -20. But again, when we have these adjacent signs, we don't write them in mathematics, so that becomes 8x minus 20. So it's a long way of saying, if this is just a negative here, then it's going to be 4 times -5 is -20. And you could jump straight to the 4 times -5 and go straight to the -20. Okay, but the way that it works is through these adjacent signs and sort of decoding, understanding that the value is negative and keeping that negative as you multiply through. So there'll be practice of that in the integer section where we would just practice doing things like 4 times -5. We would practice what is -4 times -5. There'll be lots of practice for those sorts of things. So important that we get really clear with what and how to multiply negative numbers. I'll go back to the challenge screen. I want to make sure everyone's had a chance to write down. Jump down here. There's your challenge questions. I'd love for you all to have a go at that, one of those or both of those. So please write them down or come back to the video to grab them. That would be great too. So that's it, everybody. Out of time again. Whew. These lessons go super fast. But like I said, we sort of want to focus on expansion this time. Next week will be all on factoring. As always, it will help if you come to the lesson having had a little bit of a look at it. So if you've got a textbook in your house, it'll have a chapter on factorizing or factoring. Have a little look at it. Be a little bit familiar with the idea and the concepts so that you can come with questions if you have them. So yeah, again, thanks everybody. We'll start next week with the challenge questions here. And yeah, I hope you have a great week between now and then. I see that some states have their schools going back. So if you are going back to school, oh, it'd be a shame to miss you, but you'll be able to watch the recording. So hopefully we can still keep in touch that way. So again, thanks everybody. We'll see you next week.